Hi again, and welcome back to another kitchen science video. So in the last video we talked about density. Now that's quite a tricky concept to get your head round, so I thought I'd do a quick video on what density is and how we can play with it. In science we talk about states of matter. We talk about having solids, liquids and gases, and each of those contain molecules. In a solid, they're organised in a nice sort of regimented way, and they're packed closely together so they can't be compressed. In a liquid, they're still touching, but they're able to be a bit more fluid, move around one another. And in a gas, actually the molecules tend not to touch so much, so therefore they kind of whiz around, which means they've got air between them and we can compress them together. Now, we talked in the last video about density. And sometimes we confuse density without weight. Weight is actually the measure of newtons, the measure of the pull of gravity towards the centre of the Earth. Whereas if we're talking about mass, then we're talking about density. We're talking about how many molecules we can pack into a certain area. At the minute, in between each of these Cocoa Pops is little pockets of air. Now, we could increase the density of these Cocoa Pops by doing one simple thing. Now, just before we do that, you'll see I've added a line onto this glass so we can see where the level of the Cocoa Pops was before we do what we're about to do. Right, we're going to make these Cocoa Pops more dense. Now, you can see that we've increased the density of the Cocoa Pops by squashing them together more. But if you imagine that at the start, those Cocoa Pops were molecules, we've now compressed them together and we've made the Cocoa Pops more dense. Now, it is going to be harder to be able to push through those Cocoa Pops because there's more of them in a given space. Hence, we've increased the density. Now we're going to try an experiment today to look at the density of different liquids. We're going to try, if we can, to make water float. We'll see how that goes. Now, let me guess what some of you are thinking. You might be thinking, I'm going to play you a video from the International Space Station where the surface tension of water can make water float, just like in this picture. But instead, actually, we're going to use density to make it happen in the kitchen. So to do this next experiment, we've got the following pieces of equipment. We've got this little glass here, we've got some sunflower oil, we've also got some golden syrup, we've got some washing up liquid, and then we've got some water in this glass, but I've coloured some of it red using some of this food dye just so we can see it a little bit better. So let's find out how this is going to work. We're going to pour each of these liquids into this little glass. Now it doesn't matter that it's only a little glass, okay? It would have the same effect whether it was a big glass or a little glass. And obviously by using a little glass, we're not wasting as many of our kitchen ingredients. So, we're going to start off with the most dense liquid, the one that's got the most stuff packed into it. Now, which one do you think that one would be? Which one do you think is the most dense? Is it going to be the sunflower oil, the golden syrup, the washing up liquid, or the water? It is the golden syrup. Okay, now you might be thinking about how thick it is, its viscosity, and that tells us that it's got quite a lot of stuff packed into a small space. Now we're going to start off by adding some golden syrup to the bottom of our glass. We don't need loads and loads because it's not a giant glass. Then we're going to add the next most dense liquid. Which one do you think is the next most dense liquid? It would be the washing up liquid. I've chosen a lovely blue one here for this as well. Let's see if it works nicely. So we're going to pour this in, and you'll see as we pour it in that it seems to sit on top of that golden syrup. Then we're going to have a look at our next most dense liquid, which would be the water. Now, to help me get the water in there, I've actually got myself a syringe. Okay, I'm gonna pop some water in here just on top of this one. It's tricky because if we go too fast, we'd start to get them merging together, which is what we're trying not to do. and trying to get them. You can see that little bubble of water in the middle, can't you? Just sit on top of each other like this. Perfect. Which leaves us with only one liquid left, which is obviously our sunflower oil. I'm going to add this one in last, and again I'm going to take my time to do this. I'm going to really pour carefully. Let's see what happens. There we go. So I have created my rainbow glass by looking at the different densities of these liquids. Just wanted to show you a couple of cool things. So if we look down from the top through the side of the glass, we can see through the oil these bubbles rising to the surface. Can you see them, how they rise slightly differently at different speeds through each of the different liquids? It's quite fascinating to watch, kind of like a lava lamp. You get this lovely mirror finish on top of the oil before we go into that red water. And then when we look down here, right down at the bottom, see if I can get this. You can see those bubbles in our golden syrup and in our washing up liquid. They just seem to hang there, not really moving very much at all. Whereas when we look at the bubbles that are moving through the top, they seem to rise quite quickly. Now you might remember that at the start of this video I said that I had a little ball of blue tack, and that's to show you one thing with this as well. If I take this blue tack, I'm going to drop it into the top. I want you to see how it moves through these different liquids. So it's going to go through the oil, then through the red water, then through the washing up liquid, then through the golden syrup, and that'll tell us something about density as well. Have a watch. How cool is that? So that blue tack falls slower through the more dense liquids. Obviously, there's more molecules for it to have to push out the way. It's not even reached the bottom of the glass yet. And as it moves through those more dense liquids, those things that have got more molecules in the way, obviously it moves slower because it's got to push more out the way. And we get this cool effect with the bubbles of gas that were trapped inside it rising up too. We'll try that one more time. We get one more piece of blue tack. Have a watch again, how it falls at different speeds. Here we go, in 3, 2, 1. There it goes. So it moves through the oil and the water very quickly, and then a lot more slowly through the washing up liquid and the sunflower oil because they're more dense. So there's this other cool thing that happens if you try and mix these liquids together. If we give them a quick mix, watch what happens. So over time, they want to get back to their original place because obviously each of the liquids has its own density, so they want to get back to where they first started. Very tricky to mix them together. Thanks for watching. I hope you enjoyed that experiment, and I'd love for you to have a go with it at home. Just make sure you check with parents or carers before you do any of it, and make sure you don't use up all of the ingredients in the kitchen. I'd love to see some photos or videos of the things you've been doing. So, until next time, bye-bye.